Hello everyone, myself this is Leela Madhuri from 2nd BTech IT, belongs to Sesi Institute of Technology and Engineering. In this video, I am very excited to discuss about traveling salesman problem. Firstly, what is traveling salesman problem? The traveling salesman problem, a salesman must visit 10 cities. We can say that salesman wishes to make a tour, visiting each city exactly once and finishing at the city he starts from. There is a non-negative cost C of I, j to travel from the city I to city j. The goal is to find a tour of minimum cost. We assume that every two cities are connected. Such problems are called traveling salesman problem. Here are some of the applications that was used by traveling salesman problem are post box collection, vehicle routing, automated PCB drilling and soldering in electronics. Here is a problem to solve by using traveling salesman problem. In this problem, we have to find an optimal tour with a state space tree by using this given instance. Firstly, what is state space tree? State space tree means it gives all possible solutions for a problem. This entire state space tree discusses how many paths were included to travel from each node. So this state space tree started from first node, that is I start my journey from the first node. I can travel from first node to second node to third node to fourth node to fifth node to first node, or first node to second node to third node to fifth node to fourth node to first node. So these are the all possible paths that can travel. Now we should calculate the cost, which is the main factor. Because of this factor only we can find the optimal tour. So this process starts from the bottom to top. From bottom level we had the distance from 5 to 1, that is the distance from 5 to 1, that was 16. So we place here 16. So the distance from 4 to 1, that was 19. 4 to 1, that was 19. So in the meanwhile we have to calculate all the distances in the bottom level. Then we may move to the next level. In this level I have to calculate the distance from 4 to 1, but I already calculate the distance from 5 to 1, so I need to calculate 4 to 5, then add the distance from 5 to 1. So the distance from 4 to 5, that was 3. So 3 plus 5 to 1 distance is 16. So 3 plus 16, that was 19. So the distance from 4 to 1 is 19. In the same way we have to calculate the remaining nodes. Like I have to calculate the distance from fifth to first nodes. In fifth node I calculate the distance, that is from 5 to 4. From 5 to 4 the distance is 16. So 16 plus 19, that was 35. The same way I have to calculate all the distances in this level. Then I have to move to next level. In this level I can calculate the distance from 3 to 1. But in this level I can calculate the distances from 3 to 1 in two possible ways, that is either 3 to 4, 4 to 5, 5 to 1, or 3 to 5, 5 to 4, 4 to 1. But we have to consider the minimum cost only. So from 3 to 4, that is 3 to 4 the distance is 2. Already we have 19. 19 plus 2, 21. From 3 to 5, that was 4. 4 plus 35, that was 19. So minimum of 21 comma 39, that was 21. So we consider this part, that is 33 to 4, 4 to 5 and 5 to 1. In the meanwhile we have to calculate all the costs in this level. Then we have to move to the next level. In this level I have to calculate the distance from 2 to 1. But I have three possible ways. So I consider the minimum way as before. So from 2 to 3. From 2 to 3 the distance is 16. So already we have 21. 21 plus 16, that is 37. From 2 to 4. From 2 to 4, what is the distance from 2 to 4? 2 to 4 the distance is 4. We had already 13. 13 plus 4, that was 17. From 2 to 5. From 2 to 5 the distance was 2. So here already 28. 28 plus 2, that was 30. So we have to consider the minimum one only. So the answer is 17. So I can travel from second node to first node with minimum cost 17. In the same way, I have to calculate all the distances for this level. Next, I have to move to the next level. In this level, I can calculate the distance from first node to the last node. So first node to last node, I have many possible ways, but I have to consider the minimum one, that is 28. So here is the possible path. The two optimal path to travel all the nodes is 1 to 4, 4 to 2, 2 to 5, 5 to 3 and 3 to 1. This is the optimal path I have to find. I can also calculate these costs by using this formula also. As I discussed it before, the optimal tour is 1 to 4, 4 to 2, 2 to 5 and 5 to 3 and 3 to 1 with a minimum cost 28. I hope you have understand this traveling salesman problem. Thank you so much for giving this wonderful opportunity. Thank you.